shearing stress, element rotate clockwise, element rotate anti-clockwise. And then we're going to have our stress X line. Okay, so this is our stress X. And then we're going to have our stress Y. And then we're going to have our stress Z line. Okay, and then over here, this corresponds to point X, point Y, point Z. And the first circle that we're going to draw okay, this is our first circle, and this belongs to our XY plane. Again, our XY plane is our in plane. And then we are going to draw the next circle. And the next circle corresponds to YZ plane because it touches the point Y and point Z. Okay, so this is our YZ plane. And this happens to be our plane. And finally, the last circle touches point X and point Z. Okay. And this happens to be the XZ plane. Again, our plane. So if we were to drop the shear now to find out where the shear is, so this will be our shear max, and it belongs to the XY plane. And then we have the next one. Okay. So this is shear max. And this happens to be our YZ plane. And then the biggest circle over here, this is our shear max. And this is our XZ plane. And this happens to be our out of plane. Okay. So when this is the case, right? We can see that the shear max for the three Mohr circle is a shear max, and this is in the XZ plane, right? And this will correspond to stress X minus by stress Z, and then we divide by 2. And this also can be equal to stress max minus by stress mean divided by 2. Okay, so over here, this is our stress max. And over here, this is our stress mean, right? So for this case, what you realize is that the out plane XZ has the largest shearing stress. Okay. So now we are going to draw your first time. We are going to sketch a 3D Mohr circle now. Okay, so these are all on Avenue to Learn, the images. So if you could download them, it'll be fantastic. So over here, okay, now this is not really a good example because you don't know what is in plane and you don't know what is out of plane. Okay, we don't know. Okay, because it's a cube. Remember, I was telling you the in plane is the one that has the biggest what cross-sectional area. This one you can't tell. Okay, so this is example number one. So you can see based on the transformation over there, you have x-axis, y, and z. Okay, and you can see over here, we label this space as x, and this face over here as point y, and the vertical face is our point z. And we can see based on how the stresses are acting, we realize that stress x is equal to 0. Okay, stress y is going to be positive 30 psi, and we are given stress z. This is equal to 120 psi. And we are also given that shear yz is equal to shear zy. And based on the orientation, it's going to be 70 psi. But whether 70 psi in shear, positive or negative, does not really matter. More important is the rotation of the element. Okay, that's the most important. So we're going to sketch, as I said, the first time we're going to sketch 3D Mohr circle. Okay, and as I mentioned to you all before, to sketch 3D Mohr circle, we apply what we learn in 2D a lot of times. Okay, we apply what we learn in 2D. Okay, 3D Mohr circle is not difficult at all. So this is the first time you're going to draw your 3D Mohr circle. So again, we have our normal stress line, and then we are going to have our shearing stress line. Okay, so normal stress. So we are going to have 0, 20, 40, 60, 80, 100, 120, 140, 160, 180, minus 20, minus 40, then we have 20, 40, 60, 80, and 100. So minus 20, minus 40, minus 60, minus 80, minus 100. We have shear, element rotate clockwise, element rotate anti-clockwise. So we have a normal stress at 120, right? So this is your stress Z line. Then you have a 30. So this is where our 30 is. Stress Y line. And then we have a stress Z line, stress X line, do apologize. Okay. And over here, we have our stress X. And if you look at point X, right, everything is equal to 0, right? 0 normal stress, 0 shearing stress. So we are very sure over here, this is our point X. Yeah, we're very, very sure. And then on the shear, we have 70. So you have 70 over here. And then you have another minus 70 over here. Right? So if we look at point Y, which is under tension of 30, the element is going to rotate anti-clockwise, right? So this is going to be your point Y. And then point Z at 120, right? It's going to rotate the element in the clockwise direction. So this is your point Z. And then from here, we're going to draw a straight line. Okay, we're going to draw a straight line. So from here, we can calculate, okay? We can immediately calculate our, so you write down this is our YZ plane. So we're going to calculate stress average for the YZ plane. This will be equal to 30 plus by 120. And we're going to divide by 2. This corresponds to 75 mega PSI. Okay. So we're going to draw our center, which is our shifted. Okay. So this is our 75. So this is our point O, right? And then from here, we can calculate our radius of the circle, which is tau max. So our tau max is for the XZ plane. Sorry, YZ plane again. And this will be equal to, we know the shear is equal to 70 squared plus by, we can do 75 minus by 30 squared. Okay. So this will come out to be 70 squared plus by 75 minus 30 close bracket squared. And then we square the whole thing is equal to 83.217. Okay. PSI. So likewise, we can calculate stress. Now, in 3D Mohr circle, we don't call it 1 and 2. We tend to call it stress A and stress B. Okay, stress A and B. Okay, for 3D Mohr circle. So this will be equal to 75 plus minus 83.216. So 75 plus 83.216 is equal to 158.216. And 75 minus 83.216 is equal to minus 8.216. Okay. So from here, we can draw our 3D Mohr circle. Sorry, our one of the plane, not 3D yet. So we have minus, and then we have plus 158, 128. Hold on. It looks kind of weird. 20, 40, 60, 80, 100. That's correct. Okay, so 158 is about here. Okay, then it's going to move up by 83.216. I'm eyeballing this, okay? And then it will come down by 83. Okay, so this is like 83. You know, not that 90, 83 should be somewhere around here. Okay. So it touches point X and point Y, right? So this corresponds to your XY plane. Okay. So now over here, this is known as your stress A. Okay. And over here,